Good morning to all. Very good morning to respected Director Sir, Professor Dr. Surya Prakash Tripathi Sir, dear participants, faculty members and research scholars. Now we are in third day sessions of FDP on data management. This faculty development program is meant for enhance the subject knowledge as well as the domain area of this topic of data management. Today we will interact with three different resource persons who are surely given depth knowledge about topic or issues related to data management. Today, first session, Professor Dr. A.K. Singh is going to present or going to share their knowledge, and the topic is quite useful and effective related to data management or data processing is the query processing and optimization. As we know all, effective query writing or effective query designing is one of the important issues, and all are well aware of how this effectiveness directly related to the cost of processing the data. All participants are requested to adhere the time for this session as we are started our session at 10 o'clock. All are expected to adhere the specified schedule. I welcome the resource person of the day, and I also thankful to all the executive authority and our chairman sir, joint secretary sir, dean sir, director sir for giving such an opportunity to organize such a quite effective or useful faculty development program. our resource person, Dr. Sir, join the session. Good morning, sir. Good morning, Dr. A.K. Singh, sir. Welcome to in this session, the discussion of this FDP on data management. Director sir, say something related to this.
Good morning to everybody. And today is the third day of faculty development program on data management. And today's first session is speaker is Professor Dr. A.K. Singh ji. He's a very learned person, as well as he always treats people with the most respect. He is very popular among his colleagues and his students. And I hope that we all will be benefited by his talk on today, that is scheduled from 10 to 12. It is a pleasure for me that I am inviting my students to deliver the talk, and it's a very happy moment for the teacher when his students
Thank you, sir, for your. Now over to Dipti ma'am. Please introduce Professor
Thank you, sir. Thank you so much. Good morning to all session expert and participant. On first session today, A.K. Singh sir from MNNIT Allahabad. He is working as a professor in MNNIT and having more than 20 years of experience. His expertise areas are data mining, information retrieval, semantic web, big data analysis, and data engineering. He had AICT fellowship under QIP during his PhD, and he has nominated and awarded Commonwealth Scholarship 2004 Canada by MHRD India. Sir has authored 3 books and published more than 50 research papers. Sir, I am again welcoming you. Thank you, and over to you, sir.
Hello, good morning to all the participants. Am I audible?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. You are audible. Good morning, sir.
Being part of this faculty development program, and it's an honor and privilege for me to serve to the wishes of my guru, Professor S.P. Tripathi ji. And thanks for giving me this opportunity. So, as it has been told that this is the third day of this faculty development program on data management. So, on the topic, as per the schedule, is query processing and optimization. So, I will try to take you to the need of databases, the importance of data, which must be by now very clear to you. the role it is playing in your life and in your daily life, right? It is affecting you. You are enjoying the benefits of data analytics to a large extent. So, what is data? Data models, how to query after being stored, and if even if you query, what are the different types in which you handle data according to the complex applications which are coming, right? So, and a bit of optimization into that. So, allow me to share the content of my slides so that you can proceed.
Please, sir, you can share, sir. No problem.
Okay, so this is sharing the entire screen. Fine, no problem. Okay, well, is the slides visible on
Yes,
the
sir.
screen?
Yes, sir. Yes, sir. Clearly.
That's great.
Thank you. उसका screenshot
So to begin with,
screenshot लेते रहिए बीच बीच में
what is data?
बोलने के बाद में लेकिन
You must be aware by now. But
उससे recording
briefly, you can say data is how we express observations in reusable form. So any observation you make, sometimes you try to keep those observations for making decisions on those observed facts, or you can discard them after usage. So you don't make it persist for a longer time. And then what is observation? Observation is our perception of relationships between the entities. It could be about people, places, music, and whatnot. Anything which you are using. Whether it is the address book or the phone addresses in your cell phone, your to-do list, your personal diaries, your music files, all the things. It's not that data has proven its importance now. Data has been important ever because it always formed the basis of information, whereby you can create knowledge and wisdom subsequently. So if you have decided to attend this FDP, you must have observed certain facts. And that's data. And then you must have decided to join it or not to join it, whether it is going to benefit you or not to benefit you, and finally you decided upon those facts. So whatever decision you make in your daily life, whatever decision you make when you are doing some technical computations, experimentation, the basis is most of the time the data which you process. you know that data is important, right? Because you are using it all the time. It's not only you are using, you are creating the data all the time. The data footprint is huge, right? Right now, your cell phone is sending beacons, GPS locations, all creating data, right? Your presence in this FDP is an observation, is a data for some. Your absence, those who have not made it, is again a data. Whatever you do, most of the time it remains unrecorded. With the advancements in data collection and data storage getting cheaper and cheaper, we are able to process more and more data and get advantage of it, get an edge over it. John Naisbitt's famous quote that we are drowning in data. And on the right hand side of the slide, you can see some statistics. Right? Internet users generate about 2.5 quintillion bytes of data each day. As per an estimate, every person is going to generate 1.7 megabytes in just a second. See the amount of data. You must have observed that there are some wonders happening around you, which were a decade earlier, not even much before, a decade earlier even, seems very difficult, not reachable, not achievable. They call that the advancements in artificial intelligence. You are getting more and more intelligent machines day by day. They are able to understand you. They are able to answer you, right? Whether you are using Alexa or Siri, that is digital personal assistant, or any other artificially intelligent program or agent. It is not as if that AI is new. Started journey since last 7 decades. In 50s, that we started talking about and working on it. And it has not shown much success till recently. The reason being, only which is being attributed is the presence of data and the ability to explore and process the data. You are not able to capture that much amount, and you are not able to process that much of data. So the compute is now exascale computing. And it has largely become data-driven compute. It's not process-driven. Multiple aspects, dimensions of data have been realized. On the left-hand side, you see 5 V's. They are the characteristics of data. In terms of volume, it's huge. It's huge beyond your expectation. Its velocity, 1.7 megabyte per second per user. By the time you realize the data is coming in, you need to analyze it, it's gone. You hardly have a chance to look at once only. There's a variety of data, right? It's blog, it's tweet, it's image. You're uploading continuously on Instagrams and other portals, right? The HTML, there's a size of pages that you see. Much more than that is the usage log behind that on the internet, on www. Veracity aspect talks about the trust that relates to data. Most of the data is user-generated content. You're not expected to trust on anything which is published on www by anyone, unless and until you trust the source. Because it's a user-generated content. There's no centralized control, you know that. And the value associated with that data. So there are multiple characteristics of the data, right? Which are popularly known as the characteristics of big data. The data has become big, right? So how big is big? That's a different aspect. There's another session attributed to big data computing, so we are not into that. Managing data is the title of this workshop and this faculty development program. It's very important. All right. The data which you need to process, which you are producing for your own daily decisions, or strategic decisions, or planning which you make in your own daily life. That's important. It is primal and it's universal. Core of most apps services is data. Data is the core. Whatever applications you are using, whatever services you are using. Whether the data is small or large. Whether the application is very modern or the application could be very old. Like simple, plain application like ticket reservations. Or you have apps which are modern apps, right? Managing data itself brings challenges. And they're really hard problems. Even with very small amount of data, you realize it. Many people, to be honest with yourself, you can ask a question, right? Are you able to locate the information at the time of its requirement, when and where you need it? How many times? How many times you are finding yourself banging your head against your laptop or whatever data sources you have against your files to fetch the relevant piece of document and the relevant piece of information which you need at that point of time. It's very difficult. So managing the data involves a lot of operations, lot of processing, right? So capture, to store in a way to understand, right? Store in a way to understand the data so that the data makes meaning. Sometimes you must have seen that just by rearranging the data, it becomes more meaningful, right? So whatever data or whatever data objects or whatever relationships you want to capture, you have to represent that information in a way that makes more meaning, that makes more sense. So that's why we require data model for it. And once we decide upon the data model, we take a set of application program which allows us to store, index, and subsequently query. That is all aspects of data management. And that we call database management system, that set of code, that set of application. Some open source or commercially available database management system allows you to create a repository of that data, right? Allows you to create database. Those who are from the computers background, they are aware of it. So whether it is to-do list, phone numbers, mailing list, accounts, payroll database, AKTU students database, your favorite Amazons or Flipkart's products database, everywhere you need to create a repository, you have a representation, and you have got a background database. I'll also at the end talk about that now with the advancements of complex applications, one database becomes insufficient to handle the requirement of that application. So there are multiple databases that are used, right? Part of the database is in one application, part of the data is in one type of database, other part of the data is the other part. So when we need to store data, any data elements, there's a question of how well we understand that data. And there comes the role of data model. See, representation and understanding, they are part of abstraction. Abstraction is very important everywhere and very important in computer science. That you are able to see as much detail as relevant for you. And you leave the irrelevant details behind. You cannot work on any concept, any problem, if it is not abstracted at a level which it had to be. If you want to work on digital circuits, so when you work on Carnot maps, that's an abstraction of the digital circuit behind, which doesn't talks about, it puts the current which is flowing in it. Where is ground? Whether it is copper or whether it is other element. What is the thickness of the wire, connecting wires? And lot more, what temperature it produces in the current flows. The only representation of the circuits in order to solve. When you work on a computer, you don't. There are millions and billions of ICs. You don't get to that detail. You only know the relevant details, which allows you to look at the complex piece of product, which you call your laptop or desktop, at a certain level of details so that you can work. So it implies simplification basically. The replacement of complex and detailed real world situation by an understandable model within which we can solve it. See, all of you are using a search engine, right? Every possible minute when you need to look upon information, you use a search engine. Most of you are using Google search. I don't know how many of you are aware that Yahoo came way before Google came with its search engine. There were other search engines as well, which allows to search the relevant URLs from the web as per your search string. As simple as that. Yahoo क्यों सक्सेस नहीं हुआ? Google कैसे सक्सेस हो गया? I keep this question with you, and the answer lies in the way Yahoo represented the web data and the way Google represented the web data. So it's the data is same. It's not as if the data is changed. It's the data on www on which the search is made. But the way it is represented, that made the difference. Okay, so keep this question in the back of your mind, and if you do not get it, we'll answer it at the end. So, data model is very important. One more example I can give you. Most of you have seen sci-fi movies like Star Wars. Star Wars is a very, I think, in 60s came. Or there was another movie in which there was a computer called C3PO. I forget the name of the movie. But the type of capabilities that that computer possessed, and it was visualized and filmed, people thought that, well, it may be a reality soon, that we will have a robot, we will have a computer which can understand our voice, which can understand our language, which can answer like human beings, and which can do course like we human beings do. We are good at doing things in which we have not yet been able to produce machines who are good, better than human beings. Why it has not been a reality for so long? The reason that I found, I believe actually, is again the lack of data models, the lack of power to represent the type of knowledge which they need to process for arriving at any decisions like we human beings do process it. As a human being, you are driving cars, right? Still, we are at very early stages in creating a driverless car. Unmanned driving on the road. Why we are able to do that, machines are not able to do that. Because we are not able to tell the machine the way we tell ourselves, the way we learn. This is my phone number, it is easy to tell in the database. Write my name. In the next column, you can write the phone number. In the next column, you can write the mail ID. And the semantics is clear that this is the phone number of this person and this is the mail ID of this person. Very easy to do. Very easy to tell the machine to process it. Now, if I ask you to tell the machine that the laptop which I am holding right now in front of my table, or you are holding your cell phones or laptops, if you drop it from the table, it will break down. It will fall down and break. It is very easy for you to understand, for you to represent in your mind. This knowledge is represented in your mind. But representing this simple fact is a challenge. Think of taking this challenge and telling the machine to do this. Machine to understand that, well, if it is dropped, it will fall down and it will break. Representing such knowledge has always been a challenge. And that's why I believe it has become very difficult to produce machines as intelligent as human beings. There's a test, Turing test, for the machines. Very lately, there has been a lot of efforts to create a machine which can pass this Turing test. It had been very difficult for a long time, for a very, very, very long time. Recently, they had a machine which passed it with 33% score only. Okay, let's not go into that. I just wanted to bring you back that, well, data management is important. But for managing the data, you need to store it. And for storing the data, you need to, for managing the data, you need to store it. And for storing the data, you need to model it. You need to represent it. And what you have as data models is relational data model, popular, very popular, aged, successful commercially. Then there is an advent of semi-structured data because relational data model models data in a very structured manner. The way you create, the way you organize in the form of tables. To draw columns, sub-columns, sometimes, although relational data model does not allow you to have sub-columns. So it's columns and rows. Columns are the attributes of the data object. Each data object is recorded in each row. And row is basically, you can call it tuple, you can call it record, you can call it row simply. data is, when the data is not that way structured, that is all the text data. Here was semi-structured data. Most data on the web is semi-structured. So you need a model which allows you to store semi-structured data, that is XML, let's say, for example, or RDF, which is arranged in the form of graph. With the advancements in object-oriented programming, we visualized data objects or concepts as objects which are very near to reality as compared to the way it is done in non-object-oriented programming languages. It was realized that we need object-oriented databases, which allows you to store objects rather than store the attributes of the objects. Object-oriented databases, which are largely object relational databases, built on top of relational database. That is to extend the capability of the relational database in order to incorporate objects, in order to allow objects to be stored in it. And these all require a schema. Schema is the structure which we give to the data, which we try to give the data that gives meaning to the data. But then there are schema-less data requirements, where the schema changes very rapidly. And there are applications. आपने देखा होगा कि भाई, when you do a post, initially you are allowed to post against certain product or against certain news or against certain data elements. Against that post, later on, it was thought by immediately that now you need to allow liking and disliking of a post, or to comment on your post further. So comments on comments. So it needs to be managed as a thread, each comment, which can further go multi-threads, right? And now you have seen that even the likes are of different kind. There are few types of likes. Recent advancements have seen emergence of graph databases, because the graph has got some characteristics that captures the relationship among the data elements quite well as compared to other data models. If you look at the database types, the another dimension could be that it could be centralized, it could be distributed, it could be parallel. Parallel and distributed you can take in terms of loosely coupled and tightly coupled systems, which allows you to have a parallel computation or distributed computation. Popularly, it is centralized database where you have got all the databases at one central site, and different sites are accessing the data. Right, over a communication network, they are connected. So all different organization components access the same data at the same site. Or you can allow every site to have its own database. And each of them is connected to again a communication network. It's not as if site 1 cannot access site 3. The data part at site 3 The data part at site 2 can access the data part at site 1 again over the communication method. Or a query could be posed which may rarely needs the join of the data at more than 2 sites or 3 sites or 4 sites.
इसमें कोई day 1 कर दीजिए, है ना? और इसमें session 1 session 2 session 3 यही
Right. So it's very difficult
इसी में दे रहा हूँ दो
to have
इकट्ठा करके दीजिएगा
a distributed control.
मतलब ये बना लीजिए फोल्डर तो बनाना है अब
Number 1,
डे 2 का मिल जाए क्योंकि अब डे 3 का
having and employing
बढ़ता जाएगा
centralized control, it's easier. But it has got its own disadvantages. It has got its own bottlenecks. Do not provide autonomy to individual sites for having their own schema, for having their own database. Contains data. A DBMS normally just stores the current instance. If you change the data, it's a new instance. At that instant of time, the snapshot of the data is that instance of the data. It is organized in tabular form. So a collection of tables, you can visualize it like a relational data model. Each tuple, row, record is unique. On the keys, the notion of keys, primary keys, candidate keys, will not go to that. Relationship among data is also stored as a relation. So if you have got a student, if you have got teacher, and there's a relationship between a student and teacher, this teacher teach this subject or taught this in the previous semester. So that teacher relation is again captured as a relation. And see, there is a role of metadata for querying over the data, for making the meaning of the data more easy. Metadata is the data about data, right? It's something like you have got a couple of files in your rack, or whatever catalog you see in the library when you enter, right? It's a type of index. It's a type of data about the data which is being stored, right? So that you are able to search based on author or based on title. There are normally two types of, either you search on author or you search of title. You yourself creates lot of metadata, right? And this lack of metadata makes the query difficult, right? So whatever you are querying, you are looking at your recent curriculum vitae, which you have wrote a month back, or some notification that has been received from the registrar office. You are trying to locate it. And it's your luck if you remember the keyword which is there in the file name, you can locate it. The file name again is a metadata for the files which you have stored on your desktop or laptop. The date of creating that file, the name of the file, the author who has created that file, the size of the file, they're all talking about the file. That's data about the metadata. There's a huge metadata which is required for querying over the data, right? So querying is very difficult because it largely depends on the way you have stored the data. It largely depends on the way you understand the data. You cannot reach to a product which you are looking in a superstore until you are guided and there are enough metadata available on a multi-storied mall, right? Because there are hundreds and thousands of products. The product you are looking is on third floor and on which rack, towards which side. You need information to decide upon this. Then only you can reach to that product and find it, else you cannot. Likewise happens everywhere. So metadata information is the information about the schema, the information about the programs, information about the physical storage, information about the security, that is who is allowed to access, what are the roles which are created and what are the privileges that has been granted to each such role. Storage, auditing, any information related to it, right? Data storage itself requires whether the data is organized physically at physical level. It's a flat file organization or it is a heap organization, right? I'm just giving an example. You need to make decisions at physical level, and when you are representing, you make decisions at the logical level to create a proper logical abstraction of the data which you are trying to store and later on retrieve. Now, once presuming that you have stored the relational data, you need to query over the relational database, right? Querying over relational database requires, or querying over any database requires a language, right? requires a way to access the desired data, to locate the desired data, and then only you can access the data. SQL, read as SQL, which has undergone many standards, SQL1, SQL2, SQL3, and is moving further. SQL language is almost English-like language, where we say, select this from this, where this, and some more constraints which we impose in almost liquidly. So it's an example of fourth generation language, which is almost at a very high level of abstraction. When you say, get me a cup of tea to a person, to your office person, boy, you do not tell that fellow how to fetch it, right? Which type of tea you want, where to fetch. If he's making, he or she is making, then how to do it. Whether you need a boiled mixed masala tea or it is English-like separate tea. You simply say that, get me a cup of tea. It's at a higher level of abstraction. Then you say that, okay, well, take this thermos flask, go to that shop, ask him to make tea like this, bring it back, cup wahan milega, and then get me a cup of tea. So there you express the entire procedure for getting the cup of tea, for getting the desired data element, desired data object, right? Desired information. You express the entire procedure. And when you say it at a higher level, you don't express the procedure. And that's why we call it non-procedural. If you write code in C programming language, it's a procedural programming, right? Because you simply say that do this, do this, do this, do this, step by step. You tell machine to what to do. And think of the machine where you simply say that, do this, or get me this. The steps are to be decided, to be executed at lower level by the machine itself. SQL is very powerful. Though it lacks to support the need of complex data types as per the present application's requirements. It provides standard data types like numbers, strings, boolean, date and time. There are certain additional types which differ by the vendors who implement the SQL standard and give it to you. Whether you are using MySQL, that's open source, or you are using IBM DB2, developed by IBM, or you are using MS SQL, and lot many, right? Whether you are using Ingress, Systema, as a relational database, different vendors, right? Though it does not support user-defined types, right? So if you need to store a student, you have to use these types, right? You cannot use student as an object and store it here directly. That's where it comes object relational or object-oriented database, where it allows you to store object on top of it. At a lower level, it would be relation, but the wrapper classes allows you to visualize a student object stored in the relations. Okay, well, now since you have created a schema, a database instance is ready, we can query over that. A database management system query processor, in general, takes an SQL query. Look at the diagram. Takes an SQL query. And since it is at a higher level of abstraction, you need to parse it, as you do with other programs for checking syntax and some of the semantic errors. Then if there are any other types of definition which are again relations but created for different reasons, on the base relations, you call them view. People call them virtual relations, who doesn't exist physically, but the definition exists and you can access the data based on the definitions. The way you do it in like macros. When you use a macro, its definition is replaced at the point where you have used a macro in the C program. So since the query is at a higher level, you need, in order to optimize and execute, you need a query execution plan for execution. And to prepare that query execution plan, you can optimize the steps that are involved in executing that query. That can be done. So you need to represent the query which is at highest level in SQL in a procedural way, like relation algebraic expressions, where you express that query in an algebraic expression, in an algebraic form, which uses the relation algebra operators for making it procedural. And then the steps are clear. And the sequence of the steps are also clear. Then optimization comes in, that in which sequence, if it needs to change, changing the sequence can optimize the query. Optimizing the query is in terms of speed, in terms of cost. That's all. आपको जवाब जल्दी मिले, आपने गूगल पे कुछ सवाल पूछा और गूगल ने 3 मिनट लगाया, तो आप 3 मिनट रुकने वाले नहीं हैं वहां पे. You need it in 3 seconds. 1, 2, 3, that's all. So the task is to find an efficient physical query plan for an SQL query. That is called execution plan. And the goal is to minimize the evaluation time for the query. That is, compute query result as fast as possible. The cost factors that are basis for this is disk accesses, the read-write operations, the I/O involved, the number of page transfers, right? From your cache to main memory and main memory to cache and again to, if required, to the secondary storage. CPU time is typically ignored as it's abundantly available, and most of the bottlenecks it has been observed comes from the I/O part. So querying over the centralized database involves a declarative query, that's input, right? It's declarative, it's non-procedural. So on relational database, you express it in SQL. On XML databases, you write an XQuery or XPath. On object databases, you write an object query language. In NoSQL databases, you deploy CRUD query and so on. But you give a declarative query, and then step one involves translate query into an algebraic expression for relational algebra, for the relational database. So trees of operators comes in that this relation will be operated with this relational operator, subsequently with this, subsequently with this, subsequently with this. So you have got a query plan generation. And once you have a plan, you can optimize this plan. You can select partitions of tables. And once you do it, the step 3 involves the execution. So interpretation of the result and the query generation. It's as simple as that. So one plain example, select from where the basic 3 clauses of a SQL, select what you want from the target relations where the data is to be fetched in order to get this target data. And where is the condition that relation has got lot of data and you need to access only the desired data. So you impose the condition that which records in which you are interested in. Only the Faculty of Computer Science, let's say. So that's the condition which you are imposing. So AB, from AB, the clause says, so A and B are 2 base clauses, base relations. And since you need to access data from both, they are joined. The join operation is not a basic relational algebraic operation, right? It's a derived relational algebraic operation. The basic relational algebra operation is a cross product. Cross product of A and B produces ordered tuples AB, where A belongs to capital A and B belongs to capital B. You know that. So A cross B produces M cross N number of tuples. So M tuples are there in A and N tuples are in B. So A cross B will produce M cross N. That's a huge table. Cross product produces a huge, humongous table, intermediate relation. और उसके ऊपर उस क्रॉस प्रोडक्ट के ऊपर आपने कंडीशन लगाई फॉर रेलेवेंट सिलेक्शन, रेलेवेंट हॉरिजॉन्टल सिलेक्शन, ऑल दोज रिकॉर्ड्स which you want. उसमें से एक एट्रीब्यूट चूज कर लिया हमने. So that's a plain simple example of a query tree. But the thing is this, whether this is optimal, right? So to optimize this, once you know the step, you can attempt to optimize it. Rather than cross product, you can produce a join. Join operation though involves at a lower level as a cross product. But even if you want to involve cross product, you can still further make a faster execution plan in order to save cost. So if you assume that there is an index on attribute A And since A dot A is as compared with B dot B for equality and A dot C for equal constant value, that is 35 as per the example, you can reduce the size of the relation A as only those records, only those rows for which C value is 35. And since it is an index, you don't need to scan the entire relation, right? You know that when the data is unsorted, to fetch the relevant data to look whether the data is present or absent, you have to scan it sequentially, right? And if it is sorted, you have got better ways to search. You can have simply a dictionary search, let's say, which is faster than sequential scan. You know that. So having proper indexes, reducing the size of the relation, and then joining, B का size भी reduce हो गया, B dot B, A का size भी reduce हो गया, फिर join करेंगे. So M is now M prime, which is very small, and N is now N prime, which is very small. The intermediate size is the join would be very faster. The cross product that involves it very faster, and it produces M prime cross N prime at the most number of tuples. जिसमें कि हमने A dot D ले लिया. So these are simple heuristics. Heuristics are nothing but thumb rules. कुछ आपकी जिंदगी के thumb rules होते हैं, सुबह से शाम तक आप इस्तेमाल करते हैं. That's similar to that. You have got thumb rule for query optimization, which you call simple heuristics. So enumerate alternative plans because there would be a lot of plans. Brute force would be very costly. That's why there is dynamic programming, which is involved here to search for an optimal plan out of all the plans that is there in the search space. That's where you deploy dynamic programming. You can use search heuristics to find the cheapest plan and reduce the search space. It can be seen as a classical dynamic programming algorithm which performs join order optimization. The input is join query on N relation. The output is the best join. I will not go to that algorithm. Okay. The same example with the optimal plan being selected. All right. So you have got database instances in A, database instances in B, and then you only select those tuples with A value as 35, and then join it with B value. We had two relevant tuples, CS and AS. क्योंकि बाकी attribute हमने reduce कर दिया just by doing the vertical selection, that is projection. So there's a project operator that is being used here that removes all the columns, only relevant column left. So CSAS, that's a small relation with two rows and one column. And on the A side, you have got two rows with three columns. And joining then produces only one column. And it's a hash join. There are different types of join that can involve. Hash join, merge join, block nested join. nested join. Right? So there are normally forms the curriculum of a BTech program, BTech database course, right? When we do those join operations, here we were, right? So we can summarize centralized queries as basic SQL. The clauses are select, project, join. G stands for group by actually. Very good extensibility. You can have spatial joins to support spatial databases. Now, time series extension of the relational database as a temporal database, right? You need better statistics and cost model for optimization. अभी हमने क्या किया सिर्फ heuristics based optimization समझने की कोशिश की. Every operation involves certain cost, right? In terms of the number of computations it requires, let's say. And the number of IO it requires. IO is again an operation that is involved in the step, right? So you can compute the cost associated with each step. And by choosing alternate way of doing it, you have got different costs. And finding out the root or the tree with the lowest cost. And that tree is one of the solution in the search space. There are certain trends that are appearing in terms of interactiveness during execution. And there are approximate answers. If you cannot find the correct, go for an approximate answer. Similar thing you have closely observed in search engines. Looking for an object, looking for a URL, if you are not able to give a proper search string to locate that, or the search engine is not able to locate that, it answers with the approximate, nearby, उससे मिलता जुलता, उसके जैसा, something like lagbhag or top K, especially in terms of in the domain of recommendation engines, where you are recommended with top 5 or top 2 or top K elements, data elements, which you are looking for. Okay, now let's go to query processing on distributed databases. Here you have got data on different websites and different data sites. तो क्या होगा? Relation algebra expression would be extended. There would be some more type of operators which requires communication among the different sites. That needs to be incorporated into this. So we need to extend physical algebra. So there are more set of relational algebra operators. I mean, operators that can operate. Something like send and receive operators. There is imperative need of other metrics like optimize for response time. Network interconnect becomes important here. A bus interconnect would perform differently as compared to a star interconnect or a ring interconnect. Caching and replication. See, heterogeneity in data formats and data models is going to pose a challenge in this type of scenario. I'll just create your interest in this. When there is an autonomy with the different sites to choose upon the data formats or the data models in order to create their own databases. But the requirement is that the query can be extended over more than one site. That is the data over different sites. Now the query execution engine needs to understand the different data models, I mean different schema that's being used at different places and integrate those schemas in order to arrive, in order to execute the query. Schema integration is a challenge because schema represents the meaning, right? You may be looking for a cell phone, cell number, and the other person has written as that phone number, right? As an example, as a crude example, at other site it is cell number, at the other site it is phone number. The column head, the name of the column heads, that is the attribute name. So one thing is that you can see that there is no cell number. The employees or the students at the other side doesn't have a cell number. So you cannot return with the answers. Though intelligently, the data integrator must understand that this phone number is equivalent to, semantically equivalent to the cell number, so that it can do a wrapper on that schema and make it with a different meaning in order to execute the query. मोटे तौर पे एग्जांपल देखें, कहीं पे प्राइसेस अगर रुपी में हैं, कहीं पे प्राइसेस डॉलर में हैं, $170 is answered against the rupee, so that's misleading. Because there is an heterogeneity in data formats, heterogeneity in data models. So in order to execute a distributed query, there's a need of data integration. So there are books written on data integration, right? Because that's very important, that's very much needed. Data is being generated at different places in different formats. People are storing it with different understanding, with different data models. And in order to reap the benefits of data analytics, of the big data analytics, it's a requirement. The most of it in www is generated. And the present era of usage of www. You're writing tweets, you're writing blogs. And you have got your own representation of that data. There's no standardization. And that's why the query becomes difficult. because there's no metadata. Tim Lee was the father of www, has never thought, told in some of the interviews that this would be the success of www when he wrote that code, first HTML code. And the same man gave where it is visualized that the web itself becomes more intelligent. The elements of the web becomes more intelligent. So that the agent who is looking for information over web is supported with the metadata. And it can create more rightful decisions. If you ask, and even today, if you go and ask your Alexa, plan me a holiday for, let's say, in February, mid-end, for 3 days, she'll not be able to plan. Because as a human being, if you tell your friend who knows you, he would be able to plan. Because he knows what are your interests. आप हिलसन जाना चाहते हैं, आप मंदिर के दर्शन करना चाहते हैं. So in order to make a travel plan, that agent requires the metadata, and which is available. So it is not successful. Data integration. I was talking about schema integration. So issues in distributed databases, mostly similar to centralized databases, but due to the autonomy and due to the heterogeneity, due to the different data models, due to the communication involved over the network, as I told, brings a little more complexity. Here also you do plan enumeration. Traditional dynamic programming algorithm is very large to solve this problem. So it is iterative dynamic programming is used as per the research scholars. There are different cost models that are involved. Response time models, because they are not reducing the classical sense notion of cost. You are ready to pay more rupee in order to reduce the response time. Right? So it becomes multi-objective. Response time and receive. Likewise, you can see a similar type of query with the data distributed query plan, where you have got now operators like send and receive, because एक साइड पे A है, एक साइड पे B है, A और B का डेटा दोनों को कंबाइन करके क्वेरी करना है. So what we need to do it at a place where the data is communicated. A को B पे भेज दें या B को A पे भेजें या दोनों को किसी इंटरमीडिएट क्वेरी एग्जीक्यूशन इंजन पे भेजें जहां पे क्वेरी एग्जीक्यूट हो रहा. And send and receive has got its own complexities. There are different forms of parallelism which can be employed. A parallelism के form देखेंगे, so it could be data parallelism or it could be simple pipeline parallelism, let's say. right? So total cost can be optimized, or as another metric, response time can be optimized, right? It could be a pipeline parallelism, quickly move ahead. Query execution techniques for distributed databases in terms of row blocking, multicast optimization, multi-threaded execution, joins with the horizontal partitioning, semi-joins, top-end queries, and so on. So the time is quickly running out, so we can leave the details associated with these techniques. So allow me to skip so that we can go to something more interesting. Heterogeneity, as I told, use wrappers to hide heterogeneity. Wrappers take care of data format. That is the packaging, how the data is packed. Also map from local to global schema. Finally, wrappers participate in query planning, you can see, right? So that's the way to do that integration for doing that query. Now let's move on to latest advancements as per the requirement of the data storage. So there are a lot of databases which are recent databases termed as NoSQL. It's basically not NoSQL. It is Reddit NoSQL, but its meaning is not only SQL. So not only SQL means XML also comes into that. Because XML doesn't use SQL, it uses XML. But object-oriented databases, purely object databases. There is a world which is, there are programming languages and there is database world which is based on purely object, like O3 and object store. On the other side, you have got object relational, which extends the relational database to support the object storage. Like your Oracle or DB2, popular commercial databases. So NoSQL movement is basically the whole point of seeking alternatives is that you need to solve a problem that relational databases are a bad fit for. Relational databases has seen huge success, but it doesn't fit for many applications, recent applications. So you can see it as a next generation database, mostly addressing some of the points, being non-relational, distributed. It supports high volume data with high velocity and variety, right? It's largely open source, though there are commercial deployments. And horizontally scalable. Scalability is a trait, a requirement nowadays, because the data is growing at a fast speed, right? They're also ski free. सब आज तारीख में चाहते हैं आपको चाहिए जीमेल आपका खुले. आपने कभी सोचा जीमेल जिस मेल सर्वर से आप पढ़ना चाह रहे हैं वो मेल सर्वर कभी डाउन भी हो सकता है. So you get that service from some other server as your data is replicated somewhere, let's say. Simple APIs to access the data. Eventually consistent. Consistency is a huge requirement in databases. In certain applications, especially in banking applications, let's say. So to ensure it, the transactions had the property called popularly known as ACID property. That atomicity, consistency, isolation, indivisibility. These सारी properties होनी चाहिए. NoSQL databases are still in the race to reach to a state where it can ensure ACID properties. So it satisfies itself with the base properties. It's not the end of the relational database. Relational databases will never disappear. As it seems. Polyglot persistence is a recent technology that is needed because the complex applications which your user requires different data stores. Part of the data, which is financial data, transactional data, is in relational format. It's Amazon ka data. Part of the data is in relational format. Part of the data is in NoSQL format, let's say MongoDB. Part of the data is in XML format where the data interchange happens. XML was largely developed as the language of information interchange. आप एक जगह से दूसरी जगह कुछ चीज भेजना चाहें, तो दूसरी जगह वो चीज कैसे समझी जाए? उसके मायने वही हैं जो आपके दिमाग में हैं, वो दूसरी जगह वही मायने उसको दिखाई पड़े. That's a point of, that's a notion of communication. किसी से communicate कर रहे होते हैं, आपके दिमाग में एक image होती है. You've got some image in your mind. And you translate that image through your words, which travels to other person's ears. And the voice, which is signals which are received, again, had the responsibility to create an image in the listener's mind. And if that image between the speaker's mind and the listener's mind that has been created resembles, then I am able to communicate efficiently. Else, there is a loss. Either I could not translate the way it had to be, or you cannot do that. If we are at a different level of abstraction, if we are at a different level of understanding, I am not successful in communication, you are not successful in receiving. So rather than there was the term persistence only, that the data is persistent in databases, means it's permanent until and unless it is being deleted by the application itself, by the user itself. Now it is the term polyglot persistence. Data is persistent and seamlessly integrated, although it lies in different data stores. So a huge amount of data in real time needs to be handled. Both data and use cases are getting more and more dynamic. Social networks primarily rely on graph data. क्योंकि सोशल नेटवर्क में जिस तरीके के डेटा एलिमेंट्स हैं और जो रिलेशनशिप है between the data elements, that is well represented with the graph. So there's a special type of NoSQL databases which are graph databases, recently emerging, very popular, like Neo4j. Neo4j is seeing very great successes. Panama Leaks was studied using Neo4j, and it was a big analytics success in order to understand the offshore management of transactions, fraud transactions, you can say. There is a huge turmoil worldwide when the Panama leak happens. They were studied by IICJ, International Consortium of International Journalism, if I remember. You can find it out. That was studied using Neo4j. Google again has, you can go back to the previous question. Google got the success in terms in search engines as compared to other search engines because the representation as a graph, representation of web as a graph, which the other search engines didn't do. Full text, that is semi-structured data or unstructured data, वो RDBMS में कभी handle नहीं हो पाए ढंग से, because it has got a limited data types. You can store number, you can store date, you can store Boolean, you can store float. That's all. So 5 advantages: elastic scaling, जितना चाहो जब चाहो पढ़ो करो. Supports big data, opens new dimension that cannot be handled with RDBMS. Database administrators का requirement कम होगा because it supports automatic repair, distribution, tuning. The data is handled at a higher level. So a normal user can also handle it as compared to the specific role of database administrator in order to handle the data. Economics becomes one advantage based on cheap commodity servers because it is on cloud, which can be built using even on cheap commodity servers. It can be distributed. Flexible data models, non-existing relaxed data schema. It allows you to make structural changes in the database, the schema, the schema of the database, without any overhead. Each NoSQL solution is a different data model. It could be a key value. So all the data elements are stored as key and its value, that's all. The entire new compute paradigm, which came again from the Google, that was MapReduce compute, which is at a very high level of abstraction, where you need only the code for mapper function and the reducer function in order to achieve a task in a distributed fashion. All right, where the data is also distributed and the compute is also distributed. And that all complexity behind distributing the task. See, it's easy to say divide and conquer. It's difficult to achieve. If I give you 25% under you, to get one unified task done, you have to distribute the task among those 25% and get it done. It becomes difficult for you to manage because a lot of concurrency requirements, lot of synchronization requirements, lot of communication requirements. कोई वर्कर को टास्क दे दिया आपने, वो छुट्टी पे चला गया, वो आया नहीं, पहले वर्कर ने दूसरे वर्कर को कम्युनिकेट नहीं किया, बहुत the way all the challenges which are there when you put the compute in a distributed fashion using divide and conquer. MapReduce compute paradigm was developed to hide all these complexities from the user and only relies on the processing of key value. The data it processes is in terms of key value with the mapper function and with the reducer function. So key value and document stores, another type of NoSQL database. The third is column family, column oriented. Then there is a graph oriented. First three orient on aggregates. A data unit with a complex structure, that is an aggregate. It's not just a set of tuples like in RDBMS. You can simply say that an aggregate is a collection of related objects and we wish to treat as a unit. Simple representation of the data elements and their relationships, right? Where you have got customers, details in terms of billing addresses, order payments, the products, and this. So this requires a structured type of arrangement where you have got set of tables with columns and rows. That's a traditional one, right? In terms of NoSQL databases, it is translated in the format in JSON format, right? So that is Java standard object notation. where you have initially the detail. Look at the first data object, customer, right? The details of the customers with his ID. So that's the key, right? ID is the key and the value is 1. Name is the key, the value is Martin. Billing address is again with the value. All right? So each customer is having certain orders, shipping address, create payment. So this is a way of representing the data in a NoSQL, especially in a JSON format, which is supported by NoSQL database. They told you that at the core NoSQL databases, key value, document, column, and graph, and non-core, because they also do not use SQL, right? They're object databases and SQL databases. In key value store basic characteristics, get the value for the key, put a value for the key, delete a key from the data store. These are the basic operations, right? Great performance, easily scaled. It's simple, but not for complex queries. You need a lot of aggregation before doing the complex queries. CRUD, CRUD, CRUD as is being read as a typical way of doing a query over the NoSQL databases in terms of create, read, update, delete. That is CRUD, right? So you have got key and you have got value as an example. Friends, set of values, inboxes, settings. Here comes the different representatives of key value stores. Right. Redis or Memcached, even Oracle supports this. Amazon DB, DynamoDB. Column family stores is another family of NoSQL databases, right, which are primarily column oriented. So there are rows that have many columns associated with a row key. So there's a row key and the columns associated with that row key. In column families, stores, related data is often accessed together. So you've got a row key X, right, with column 1, column 2, column 3. Row key Y, again with column 1, column 9, and column N as the example it shows, right. So we access rows of data based on the row key. This is the way the different versions of the HTML pages, because HTML pages, websites go frequent modifications. ठीक है ना? तो जो सर्च इंजिन्स आपको क्या कहते हैं, those who are indexing, so they do not replace the previous HTML content, previous website content. They create a new version, right, with a different time stamp. Let's say homepage of the Motilal Nehru National Institute is changed twice or thrice a day with some notices coming in new, right, each time. So the crawler which is crawling the web and gets the change modified web page creates a new version based on the same key actually. Key must be www.mit.ac.in. That is the row key. Different column values, of course, with different timestamps. So Google Bigtable is actually patented by Google, and it was initially developed as a column store family database. Still, it is used by Google only, Google Bigtable, right? It's patented. But similar to the techniques, the Cassandra was developed, and HBase is also there, which are available for others to use, right? Again, the interfaces are CRUD and SCAN on this. So Google Bigtable, HBase, Cassandra, Hypertable, SimpleDB are the example of the column families. Likewise, you have got document database, right? Where the documents are the main concept rather than columns, rather than the keys and the key values. So the documents could be either XML documents or JSON documents. These documents are self-describing, hierarchical data structure. You must have seen the XML documents that contains data along with the structure itself. Documents in a collection are expected to be similar, although their schema can differ. That's why it allows you to handle the frequent changes in the schema. So this is an example of document store where you have got the key and the document. Popular databases are CouchDB, AmazonDB, MongoDB, right? Which is very suitable for doing compute using MapReduce and querying over it using CRUD queries, right? So it can be MongoDB, Couch, Orient. Not many things are coming up. Few more minutes to summarize at the end with the graph databases. To store entities and relationship between these entities as a graph. Node is an instance of an object, and then nodes have properties, right? Every node is an instance of some object. It has got properties. And the more important is the edge between the nodes. And that has directional significance, right? So each edge could be of different type. Normally a graph could have a collection of vertex and edges. G is equal to VE, right? Where V is a set of vertex and E is a set of edges. The edges we think, the vertex we think are of all same type of nodes and same type of edges, meaning representing similar meaning. But in graph databases, you have got different types of nodes. Each node is of different type. One is student type, the other is faculty type, and the H will be a relationship between them. And there will be more than one relationship between them. So H have types. So if there is an edge between two nodes, it could be representing likes, that this person likes this, or this person is a friend of this. Right? So nodes are organized by the relationships. And this allows to find interesting patterns. The queries goes like get all nodes employed by a big company, like NoSQL listed. We can represent this query and execute it once the data is properly instantiated in any graph database like JSON, like Neo4j. So, what I wanted, and to summarize the talk, we initiated with the importance of data, then storage of data, and querying over the data. Right? Storage requires a data model, and then there's AMI, and the query language. Once we are adept with the query language, we can go for optimizing that query in terms of costs. Query optimization in NoSQL databases is still very nascent. That's in early stages, right? So that's all about the talk. And if we have some queries among the participants, we can take.
Thank you, sir, for your in-depth and valuable, informative session on query optimization and query processing. Sir, it is quite useful and very much applicable to current scenario where we are using our database want to use our database in effective manner. One question, as I am also a student of this database subject, sir. One question from my side also. Is there any relation of this graph-based database with the network model we used earlier? Both are same or
network model, Bhavesh,
yes, sir.
is a very simplified way of looking at the graph database.
Yes, sir.
So there is no relation as such. But you can see that while looking at the network model of the data, that was hierarchical in nature actually,
Yes, sir.
and it represents the relationship between the data elements to a certain extent, right?
Yes, sir.
So it's not exactly the same. There is no relationship as such because in the recent graph databases, there are very complex types of, it supports very complex type of data applications.
Yes, sir.
Where you have got the support of even schema-less data
Yes, sir.
modeling, right? And it supports the scalability, it supports different types of relationships and with different types of nodes, which was not there with the network data model,
Okay, sir.
right?
Nowadays, we are moving from a semi-structured database to this graph-based database, sir.
No, it's not that the semi-structured databases are done with, right?
Okay.
Semi-structured databases will always be there as long as semi-structured data is there, right? Moreover, XML has got a different use in terms of the language of information interchange actually, right? So when we need to transfer some data or some information over the web from one point to another point with a requirement that the other person must get the meaning what I mean with this data, so there comes the use of XML where because you can define your own and user defined tags that adds meaning to the data and the same meaning is taken by the recipient on the other side because of the usage of the namespaces because you deploy standard namespaces and you refer to that and your document carries that reference that the meaning of student as a tag is defined in this namespace, right? And that is being taken with the document itself, with the transfer itself, right? So you can refer to the same namespace and get the same meaning of the student tag or the book tag or the whatever tags you have defined as a user, right? So semi-structured database are there and will be there as I think. So graph database is not going to replace them. Therefore, different requirements.
Thank you, sir. Your nice delivery on this query optimization. We also got a lot on NoSQL, the usability and advantages of the NoSQL, and also the concept of graph database also. Thank you, sir, for your nice discussion. Our director sir also
Thank you, Bhavesh.
Yes, sir, thank you, sir. Our director sir also wants to interact with you, sir, perhaps.
प्रणाम प्रणाम। चलिए यूटेंस द स्काई, हम तो हमेशा चाहते हैं कि बिल्कुल आप बहुत आगे बढ़े। हमारी शुभकामनाएं, हमारा आशीर्वाद हमेशा आप सब लोगों के साथ है। और मैं पूरे 2 घंटे तक आपका ये टॉक सुनता रहा। मैंने केवल वीडियो और ऑडियो ऑफ इसलिए किया था कि डिस्टर्बेंस है। आपने बहुत ही अच्छा बोला और आपके पूरे टॉक में ऐसा टॉक था कि हर आदमी बहुत ही ध्यान से सुन रहा था, बहुत तेजी से ले थी, बहुत धीमी लिसनिंग करती, तो अच्छे से आपने बोला मंत्र आशीर्वाद शुभकामनाएं आपके साथ है। मैं समझता हूँ कि क्वेरी ऑप्टिमाइजेशन पे जो लोग भी पर काम करना चाहते हैं, सबसे सिंह साहब से व्यक्तिगत से ईमेल से फोन के माध्यम से अगर पत्र सूचना है तो मुझसे उनका फोन नंबर लें और वो हमेशा ही आपकी मदद करने के लिए जब पढ़ते थे तभी सबकी मदद करने के लिए तैयार थे। जब वो शिक्षक हैं, अध्यक्ष भी हैं आजकल, तब भी वो सबकी मदद करने के लिए तैयार रहते हैं। और हम सब शिक्षकों का ये दायित्व है कि हम जीवन में प्रतिदिन इनोवेशन लाएं और भारत को पुनः जो है विश्व का हर क्षेत्र का विश्व गुरु बनाएं। इसी के साथ आप सब लोगों को बहुत बहुत धन्यवाद।
Thank you, sir. Thanks a lot.
Thank you, sir. Thank you once again for your for sharing your valuable time with us, sir. This session will be surely benefited with your discussion and I assure you, sir, this will surely the research work and the knowledge enhancement.
सबका इतना आशीर्वाद मिला, आप लोगों का अच्छा ऑडियंस मिला।
जी सर,
यही मेरे लिए
very informative session, sir. We are just enjoying your session.
Thanks.
Thank you, sir.
I'll take your leave.
Okay, sir. Thank you.
All the best.